Good morning, guys. Sorry I'm not in school today. So what we're going to do is instead of having your calculator quiz today, and then I would have done this lesson, which I'm about to do tomorrow on Friday, just flip-flopping. All right, I'm going to watch this video on imaginary numbers, and then tomorrow we will take the quiz. All right, the calculator quiz, and the same thing that I was going to do today. You're going to have opportunity to ask questions, anything that you don't understand yet for the calculator quiz, and then we'll take the calculator quiz, the second part of class on Friday. All right. So that being said, we're gonna watch this video. Then there's a worksheet also that goes with it. That worksheet will not be due until Monday. All right. So all right. So we have some square roots here to start off with. If we look at this first thing, square root of 9. All right. Obviously, all right, square root of 9 is a perfect square. Hopefully everyone knows that the square root of 9 is 3. All right. Well, what happens if we have a negative underneath a square root? All right. There is, 3 times 3 is 9, but, it's not even, can't even say negative 3 because negative 3 times negative 3 is positive 9. All right. We've been told that we cannot have a negative outside of, inside the radical, sorry. All right. Well, we can now because what we're going to be doing is talking about I, all right, in imaginary numbers. All right. And what we have for I is actually the square root of negative 1. So it is possible, if I wanted to rewrite this, I can rewrite this as the square root of negative 1 times the square root of 9. Well, I'm telling you that the square root of negative 1 is I, and the square root of 9 is 3. And so that means the answer is 3i. All right. So what we are going to do anytime we have a negative inside of the square root like this, all right, what we are going to do immediately, so like say we had the square root of negative 16. As soon as you see a negative inside of the square root, you're going to make the inside positive by just putting I on the outside. It's almost like pulling on an I. All right. And it's I root 16. Square root of 16 is 4. 4i would be my answer. All right. So you're automatically just going to, when you have a negative, you pull out an I and then you simplify the radical just like you normally would. All right. Just like you normally would. All right. Now I'm going to come back to all of this in here in a second. All right. Because I means the square root of negative 1. All right. So just a quick little recap on simplifying radicals as well. All right. Square root of 18. All right. A lot of you probably can do this in your head and be like, oh, that's 3 root 2. That is the correct answer. Some of you are like, right now, how in the world did you just get 3 root 2, Mr. Giller? Well, there's a couple different ways you can do it. Some people like to think, all right, what's the perfect square that goes into 18 and try to break it up like that? The square root of 9 times the square root of 2. And then the square root of 9 is 3. There is no square root of 2. So we get 3 root 2 that way. All right. And that's fine. All right. The way that I would recommend, if you can't just do it quickly in your head and you struggle with it a little bit, is one way that will always work is if you do a little factor tree. All right. So just find any two numbers that go into 18. Say you didn't know it was 9 and 2, but you knew it was 6 and 3. And then I break down 6, and that's 2 and 3. So I broke it down to 2, 3, and 3. So since we're doing a square root, what you do is you look for 2 of one number. In this case, we have 3. Anytime you have a pair, you take one of those, and that goes on the outside. And then whatever's left, in this case, is the 2 that didn't have a pair, stays on the inside. If you have more than one pair, you multiply the numbers on the outside. If you have more than one number left, you multiply them on the inside. So all different ways of getting through root 2. The bottom line, as long as you can simplify radicals any way that you know how to get the right answer, do that. All right. If you not remember any way, I would go with the factor tree way. All right. Now, so what I was saying with the negatives, all right, we would do this the same way. As soon as you see the negative, the only difference is you pull an I out right away. All right. Pull an I out. Now you would do square root of 18. Say you didn't know what it was. 9 root 2. 9 and 2, 3 and 3. And you're like, oh, 3 goes on the outside. So it's 3I root 2. So the only difference, all right, is the fact that you have an I in your answer. That is the only difference at all. Okay. So if, let's say, I had the square root of, let's say, negative 54. All right. Take a second and see if you can find the square root of negative 54. All right. So you should have just made this I root 54 right from the beginning. All right. Then 54, it's 9 and 6 is 54. 9 is 3 and 3. 6 is 3 and 2. All right. So I have a pair of 3s. I have another 3 here, and there are 2, but there's no other one to go with it. So you pull out this 3 up front. So I get 3I root. There's a 3 and a 2 left, so you multiply those, and you get 3I root 6. All right, 3I root 6. And that is the answer to that. So anytime, the only difference with simplifying radicals, like I said, when you have a negative, is you just have an I on the outside. All right, now a little bit more about I. All right, and what we call the cycle of I. All right. So I is equal to, all right, the square root of negative 1. Okay. So if I did I squared, what would I squared be equal to? Well, I squared would be the square root of negative 1 times the square root of negative 1, right? Which anytime you have a radical multiplied by itself, it just gives you what's on the inside. So I squared, which is very important to know, is equal to negative 1. All right. I cubed would be I squared times I, which would be negative 1 times the square root of negative 1, which is just negative square root of negative 1, which I am going to call, what is the square root of negative 1 though? That's I. So it's actually just negative I. All right. I to the fourth. Well, isn't I to the fourth I squared times I squared, which is negative 1 times negative 1, which is just 1. Now, the nice thing is if I were to continue doing this, I to the fifth would end up being the square root of negative 1, which is just I. I to the sixth would be negative 1. You can just trust me on this. I to the seventh would be negative I. I to the eighth would be 1. I to the ninth would be I. If you notice, every 4 has the same repeating pattern. All right. And that's what we call the cycle of I. All right. So what you need to know is obviously we have I is equal to the square root of negative 1. We're not going to write square root of negative 1, though. We would just write I. All right. I squared is negative 1. Very important to remember. I cubed is negative I. And I to the fourth is 1. All right. This is the cycle of I. This is going to come to play in some of our examples in a little bit. All right. Which we'll refer back to that. All right. All right. Continue here doing a few more operations with radicals, and then we'll get into the cycle of I a little bit more. All right. Now, just to review, when you're multiplying radicals, inside times inside, outside times outside. So 2 times 8 is 16. The square root of 16 is 4. There would be your answer. Okay. If it was 3 root 2 times 2 root 8, you would get 6 root 16, which would then be 6 times 4, which would be 24, right? Outsides by outsides, inside by insides, anytime we multiply radicals. All right. Now, when we have a negative in front, all right, a common mistake is this, is that you guys are going to think, oh, negative 2 times negative 8 is positive 16. The answer is 4 because square root of 16 is 4. That is wrong. When you have a negative, before you do any of these operations, you have to pull out the I. So this is really, I'm sorry, mouse got a little stuck here. This is I root 2 times I root 8. So then when we do outside, that's supposed to be a 2, everybody. Sorry. All right, when we do outside by outside, I times I is I squared. 2 times 8 is the square root of 16. So it's I squared times 4. But what is I squared equal to? All right, if we go back to our cycle of I, right, I squared is -1. Anytime you see I squared, it's -1. And you'll get so used to, we'll see it so many times. I squared is -1, so -1 times 4 is -4. So the answer is -4, not +4. Right? So when you're doing operations with the square root like this negative, multiply them, pull out the negative first. All right. All right. All the rules that we're doing here are the same if it was x. The only difference with I is that, it has a value. All right. I is the square root of -1. So when we were doing this, this is -3i times -3i times -3i. So -3 cubed is -27. Then we have I cubed. But what is I cubed equal to? All right. I cubed is -I. So it's -27 times -I, which is +27i. All right. Your final answer with imaginary should only have an I in it. There should not be an I squared, an I cubed, an I fourth, I the fifth, I the sixth, I the seventh. You have to convert it back to I, or if it's like I squared or I the fourth, it will, the I will disappear. Okay. So how could I do something like I to the 27th? All right. Well, I to the 27th, I don't want to do like that cycle 27 times. I know that it repeats every 4. So what we're going to do is figure out how many times is 4 going to 27? Well, it goes 6 times with a remainder of 3. All right. So if it has a remainder of 3, what do you think it's going to be? Well, remainder of 3, all right, is going to be I, same thing as I cubed, which is -I. So this is the same thing as -I. If you got a remainder of 1, that's the same thing as I. A remainder of 2 would be the same thing as I squared, which would be -1. Obviously, remainder of 3 gives us I cubed, which is -I. And there's no such thing as a remainder of 4, because a 4 means it just goes in evenly. So if a remainder is 0, that's what it's going to be equal to 1. All right. So whenever you can convert any I to some high power by just dividing by 4 and seeing what the remainder is. All right. All right. A complex number. All right. And the standard form of a complex number. All right. Standard form of a complex number is A plus BI. All right. Where A is the real part and BI is the imaginary. So for example, I could have an answer of 3, and I should be here, sorry, plus or minus, doesn't matter if it's positive or negative. 3 minus 2i. All right, that is a complex number. It has a real part, 3, and an imaginary part, 2i. All right, we do not write it as -2i plus 3. We always have to write it with the real part first, the imaginary part second. All right. All right, so we have 2 complex numbers being added. Okay. Now, the nice thing about this, when you're adding complex numbers like this, it's just like adding like terms. You add the real parts and you add the imaginary parts. So 5 and -3 would be 2. 2i plus 4i is 6i, and there is my answer. All right, 2 plus 6i. Exactly what you would assume it would be if you guessed the answer. That's what it is. All right, just like if I was x. All right, just combining like terms. All right, so what do you think I'm going to do here? If this was all x's, what would you do? Well, Most of you hopefully are saying, oh, I would distribute. That's exactly what I'm going to do. So negative 4i times 3 is negative 12i. Negative 4i times negative I is positive 4i squared. Okay, now you only want i's. You have to do something with this I squared. What is I squared equal to? Negative 1. So negative 12i minus 4, because 4 times negative 1 is negative 4. All right. So this cannot be your answer, though, because it's not in standard form. You have to put the real part first. So negative 4 minus 12i. There is your answer. All right. To the next. All right. So for this one, all right, we're going to treat this just like it was x minus 3, x plus 2, and we would FOIL, right? First, outers, inners, last. We're going to do the same thing here, right? So negative 3 times 3 is negative 9. Negative 3 times I is negative 3i. Negative 4i times 4i times 3 is negative 12i. Negative 4i times I is negative 4i squared. Okay? Then what we're going to do is combine the middle terms like we normally would. And it would be negative 15i. But what is negative 4i squared? That turns to a positive 4 because I squared is negative 1. All right, so you have to remember, this is the one you'll use the most. I squared is negative 1. All right, so then negative 4, 9 plus 4 is negative 5. And notice I put the real part first. I get negative 5 minus 15i, and that's my answer. That's a 15. I know you can't tell. I apologize. All right. Now, I would like you to try number 12. All right, and then see what you get for an answer. And then something is very important about this one. All right, what you should have hopefully known is when you do 3 times 3, you get 9. Then you get a negative 6i and a positive 6i. And then you get a negative 4i squared. All right, the important thing I want you to notice is that the negative 6i and positive 6i's cancel. All right. Now, the reason they cancel is because what these are called, notice how it's 3, 3, 2i, 2i. The only difference is the plus and the minus. All right. These are called conjugates. All right. So, for instance, x plus 3 and x minus 3 are conjugates because it's the same term. First, x and x, 3 and 3, just different middle signs. All right. Anytime you multiply conjugates by each other, right, two binomials like this, the middle terms always cancel. So if you ever notice this, you don't have to worry about FOILing. You just have to do first times first, which is 3 times 3, which was our 9. And last times last, 2i times negative 2i, which is negative 4i squared. And what's negative 4i squared? Well, negative 4i squared, I squared is negative 1. Negative 4 times negative 1 is a positive 4. So 9 plus 4 is 13. That answer is 13. All right. I squared in a term just changes the sign. So negative 4i squared is positive 4. Negative 100i squared is a positive 100. Positive 99i squared is negative 99. It just changes the sign. All right. So those are conjugates. Now, don't be confused with if you have something squared. This, you can't just do 2 squared and 3i squared. This means 2 plus 3i times 2 plus 3i. All right. These are not conjugates. These are both plus. So this you have to FOIL out. The middle terms do not cancel. So it ends up being 4 plus 6i and then 6i, which is 12i, plus 9i squared. 9i squared is really negative 9. Negative 9 and 4 is negative 5 plus 12i. Remember, you have to write it in standard form. So you get negative 5 plus 12i. All right, last two. Okay. So with this one, all right, we're just gonna multiply these. So 5 times negative 2 is negative 10. I to the 31st times I to the 8th is I to the 39th. All right, just add the exponent just like you normally would. So what I want you to do is take a second now and see if you can figure out what I to the 39th is equal to in the cycle of I. All right. All right, hopefully you figured out that 4 goes into 39 9 times, can't make my nines, with the remainder of 3. Remainder of 3 is the same thing as negative I. So I can replace this negative 10 times negative I. Negative times a negative is a positive. I get 10I. And there's my answer. 10I. All right. All right. Last problem. Why don't you guys try this one? All right. Negative 2I times negative 6I times 3I. All right. So negative 2 times negative 6 is 12. 12 times 3 is 36. I times I is I cubed. All right. So I get 36I cubed. And what's I cubed equal to? I cubed is equal to negative I. So negative 36I. All right. And there's your answer. Negative 36I. All right. If you wanted to, you could just done the first 2 times the first 2 and gotten 12I squared, which is really just negative 12. Then you could have done that times 3I and then negative 12 times 3, which is negative 36, and still got negative 36I. All right. All right. So that ends the lesson for today. All right. We are going to continue with imaginary numbers, next week as well. So today, there's a worksheet attached on the classroom. Try as many of those as you can and get those done by Monday. All right. So don't worry about doing that tonight. Do that over the weekend. Make sure you're ready for the quiz tomorrow on the calculator. Have your calculators charged and ready to go. And then next week or the weekend, get this done. Next week, we'll continue with imaginaries. And the reason we're throwing imaginaries in here is because it goes right with quadratics, and we start solving quadratics, which is the next thing we're going to do. All right. So I hope you guys all have a great day, and I will talk to you guys tomorrow.